Professor Lobster. There's a wise old man from the bottom of the sea. He's come to help both you and me. How things work and how things go. Anything you want to know. So if you don't know, I want to know. If you don't know, I need to know. If you don't know, I've got to know. Just ask. Professor Lobster, Lobster, build a house for me. Somewhere I can go to watch my TV. Professor Lobster, Lobster, show me something new. Show me something. Maybe when I'm older, I'll know as much as Professor Lobster.
What are you doing, Prof?
I'm blowing bubbles.
I can see that. What I meant is why?
Well, that's a good question. If you don't know, ask. Well, what I'm doing, it's rather hard work really, but it's fun as well. But I'm trying to blow perfect, simple, beautiful structures. They're a bit like tents. They're beautiful.
Tents?
Yes.
I thought this show was all about buildings, not tents.
Well, it is. Tents are like buildings. I mean, nomads live in tents. The American Indians lived in teepees for generations. It was the equivalent of a house for them. And a big top at a circus is just like a big building. Now, you don't believe me some of the time, do you? Now, what we're going to do this week is look at some totally different, original structures. You've never seen anything like some of them before.
So what's on the menu then, Prof?
Well, we've got fabrics this week. Now, fabrics are materials, a bit like dressmaking, that you connect together. Materials to make tents out of. Original different buildings. And we've got our old friend, tension. That stress that pulls materials apart. Very important in fabric structures to hold them down to the ground. And we've got patterns. A bit like dressmaking, really. All the pieces that you connect together.
And you connect them with things like buttons, poppers, hooks and eyes, Velcro, things like that?
Well, yes, in dressmaking, but in building, the connections are often as important as the materials themselves. You couldn't build a brick or stone wall without mortar to connect them together. And with timber, you've got to have things like pegs or screws or nails. And if you're connecting with steel, you need to weld it or you need bolts. But when it comes to fabric, what you've got to have is seams to connect them together, and you perhaps glue them, and you have things like steel cables and all sorts of different connections to make completely original modern structures. Now, the other thing is the loading, because being tent-shaped, the wind behaves in a different way than buildings which are usually 4 square. And if you've ever been in a tent at night, when you've stayed out in the garden sometime, or if you're out camping, and the wind blows, the tent can flap, and it's quite frightening. Oh, I see you're still learning about structures, aren't you?
It's more like fun than hard work.
Well, there's no reason why it shouldn't be fun. Now, what I want to show you now is that if you take a pretty fragile material like this soap here and blow on it very, very carefully, you can extend the size of it. Oh, try again.
I know what you're going to say next, Prof.
What am I going to say?
You're going to say if you take this bit of soap and a little bit of water, it's a really economical use of material.
Hey, you're absolutely right. Those were my lines. This is my show. What are you doing?
No, it's not. It's our show.
You're absolutely right, Liz. It is. Now, let's have these bubbles again. Now, if you blow very gently, the big thing with bubbles is... Oh, that's the smallest bubble that we've ever seen. Next, I've got a surprise. Now, this is it. Look at this. Now, what do you think that is?
A briefcase?
No, it's a building. Inside this is some material that's big enough to build a space enclosure, that means a tent really, that can take 50 people. Believe me, 50 people. Come on, let's go and put it together. Right, here we are with the red dispatch box. And what we're going to do is open this building out now. Come on, helpers. You take one end, Liz, and we'll open this out. It's like a parachute, really. We mustn't get it all mixed up. It's nice and big. Now, how are we doing? Is that right? It's tinkling a little bit to that end. I want you each to take a hook, right? Be very careful, don't rush at it, there's yours, right? One each, spread it out carefully, no hurry, and put it on the middle hook of these supports. And all do it at the same time. Come on, Angela, we'll have a good struggle. The last one's very hard, lots of tension, and it's made a lovely piece of structure.
It's more like a trampoline than a building, Prof.
Well, it is a bit like a trampoline, but it hasn't got enough tension in it, and the material isn't strong enough for it to be a trampoline. But what this is a model of what a big structure might be. Now, when they build a modern tent structure, they use a plastic-coated fabric which is strong and it keeps the rain out. But what we can do with models like this is test different forms and see if they look right and you know, look at the stresses in them. See, if I get a pair of ladies' tights, these are women's tights, pull that. Well, pull it and see. If you pull this, look how much nylon extends. Let go of it, and it comes back to the original size. Now, I've got a piece of material here that's the same that this is made of. Pull that and see. This is a modern material. It's nylon, and it stretches to twice its length and then just comes back again. So what we can do is make test models with this. And you can see here, when you look down it, we've drawn a square grid on this material, and look at the way it's gone curved when it's stressed. It shows the stress in the structure. Right, so this is a model. Now, what I want to do now is go to a real building that used a model like this to, in fact, find out what sort of structure it would have. And the clue is, I think it'll knock you for 6.
Hi, Captain. What are you doing, Prof?
Well, this is a boatswain's whistle. They use them on ships in the Royal Navy. And this is a mast. It's a very strong steel structure. And so are these booms that come out there, going sideways. And also, we've got these steel cables that are pulling the whole thing together in tension.
But why are they building a ship at Lord's Cricket Ground?
Well, they're not building a ship, it's like a ship, but they're building a tent.
Tent?
Yes, a tent that makes a roof. This is the tent. It's like dressmaking on a big scale. Can you see? All these are the different pieces. They're all numbered.
Hold on a minute. First of all, it was a ship. Then it was a tent. And now it's a dress.
Well, they're all similar. You have to have a pattern.
I don't know about dressmaking.
Well, I don't know that much about it, but it's like building this big roof because all these pieces are numbered and they're all laid out like a dress pattern on the floor and then they're connected together with welded seams. It's not stitched, but it's a big, strong plastic roof.
Dress.
Oh, it's not a dress, it's the roof. Now, this was a very complicated pattern because the building goes on a curve, and it's curved because the end of the Lord's Cricket Ground is curved. That's what they play. Now, this roof has 6 masts, and they're going to lift parts of the roof structure up, this tent, and also they're going to be lifted in the middle here. Can you see those diagonal braces that come down? They're in tension, and they're going to lift the roof as well, so it'll have 11 peaks as it goes along. And look how this is fixed. This is where it pulls back to give it tension. Now you can see the cable comes through the edge of the tent there and down here through the sheave, and there's another one comes through there, and finally they're pulled tight here, see, just tension there. Now these plates here in steel are galvanised to stop them rusting, and you can see all the bolts are spreading the load across the edge of the sheet, and you can see here the connection between 2 sheets that are brought together, and they go up to that collar that's being lifted, and you can see the tension bars and the mast. What are you doing, Liz?
I'm making a dress.
Oh, I thought this programme was about tents.
It is.
Oh?
It's quite simple, Prof. When you're making a modern tension structure, you've sometimes got to cut the material to a pattern.
Why?
So it falls in the right positions.
Why?
So it makes a neat, elegant structure.
Oh, I see. Very good. What are you doing inside that red circle, Liz?
It's fashion, Prof, and it's not a circle.
Well, it's lovely. My goodness, I know what it is. It's a tent. Those 8 segments of materials, almost triangular in shape, are hanging in tension in a curved form and being pulled out by a little steel wire in the outside of this. Let's see what it's like when you move round slowly. Wow, that's pretty good. Now, if you go a bit faster, something funny might happen. Go fast. Wow! We're back at Lord's Cricket Ground, and it's quite an exciting day because they're taking the scaffolding down. This is one of the supporting members of the roof, the mast. Here are the booms, and finally, they've lifted this beautiful tented canopy at Lord's. It's even better on the outside, and I want you to come and see this because it's one of the last times we'll get this particular view. The mast pokes up through the tent fabric here, And you can see all the shapes of those in tension. It's hanging down. And the most important member is this curved steel cable on the edge which holds it all down. It doesn't matter that it moves, and looking at it, it's really beautiful. It looks like a series of mountains or tents, or better still, like the sails on a clipper ship. So the design of this is based on yacht technology, tension cables and fabric in tension. I think it's beautiful. It was very dangerous up there on top of the roof, Liz.
Professor Lobster, I would have thought you'd known better than putting an umbrella up inside.
Well, we're not inside a building, but this gives me a good excuse to show you the simplest tension structure I could think of, an umbrella. It's got really good struts, a shape, canopy umbrella here with pieces cut to shape and a curved edge that means it's in tension, just the same as this roof up above. Can you see all the seams connecting the different shaped pieces? And the form of it, the curves, again, are all in tension, and just like the umbrella, it's got curved edges. Umbrellas and kites and tents, all...
Possible, God.
Oh, well, we'll talk to you out there. What they've got is systems that hold them down, ropes and things of that kind. But ropes stretch and rot, so in buildings, you'd have steel like this, which will last a long time. But that's not the only sort of tent structure there are. There's one here which is a triangular tent, a pyramid tent, which has been used for a long time. A pattern like this was used by Scott of the Antarctic, and they're very strong. Now, here is a much gentler tent, but it's built on geodesic principles, and it's got an aluminium frame here, and it's really quite nice with a separate lining inside, and quite big. Nice light tent. But this is even more interesting, because this tent, you go high up in the mountains with this, and you might have to live in it for a few days. So the tent breathes. It's called a micro-porous material, which is got holes in it which are small enough to keep the rain out, but big enough to let cooking smells go out. And it only weighs 3.5 kilograms, 3 bags of sugar. A splendid tent. Now, this is a different kettle of fish, isn't it? This is being inflated by compressed air. And it's an air-supported structure, so it's a very unusual tent, and they use them in emergencies. Sounds a bit like an emergency here just now. Now let's see what happens when we lift it. When you lift this up, what you can see happening, here's the structure. It's like black inner tubes in a car, and up it goes, and the fire brigade use these structures in chemical fires. The firemen go inside, and there's a shower inside, and they get decontaminated. It's a very nice emergency structure. Now, I want all the helpers to come back to the tent and build another tent for us. 2, 5, 8 and 11 to the bottom, please. Now 3 and 4 to the top, please. Now this is a very fine, symmetrical structure.
What's symmetrical mean?
Well, what I mean is it's evenly balanced on either side. Can you see how the forms come up to 2 peaks, and the whole thing is beautifully curved and very, very peaceful. 1 and 12 to the top, please. Come on, Angela. That's it. 2, 5, 8 and 11 to the bottom, please. Now this is more interesting because it's asymmetrical. There's more variety in the shapes. And it's also useful to engineers because when they make a test model like this, they can see that in certain places the structure's lying a little bit flat. Now if there was a snow load on this, this would tend to get depressed. And it would also catch the wind in an unusual way. So they prefer to see the structure having curves in both directions. So if I move this one, I'll put that down. You see, you get a better curve going over there, and it's a more balanced piece of structure at that point. Now, it also reminds me of a very interesting original building that we're going to go and see.
All right then, Prof, what we're doing in the middle of the woods carrying a great big hulking pole, and there's no building in sight.
Yes, there is. There's one up here. We're going to a building made out of great big hulking poles like this. This is called a thinning.
Yeah, but this programme's about tents and tension, not wood.
If you look at the roof of the building, you might think it's a tent. Well, it's like a tent. It's a plastic-coated sheet on the outside and canvassed with timber on the inside. And it's a strong, low-cost solution. And it's built out of timbers like this. This is a thinning. It's been cut down so that the other trees can grow stronger. Now, thinning wood is usually waste. They use it for firewood. They used to use it for pit props, but they don't anymore. But the interesting thing is that it's strong in tension. And they've used it in a very interesting way in this building. And it's the connections that are interesting. Let's have a look inside, Liz.
It's just a load of old telegraph poles.
Well, it's made out of trees like telegraph poles are. This is a tree trunk, and what they've done is they've stripped the bark off, and then they've connected all these tree trunks together to make the structure. And what I like about it is the way it's all slightly irregular. There's no squares and rectangles in it, because the timber's not been cut into square shapes.
Professor?
Yes?
It's not very smart, though, is it? I mean, I wouldn't like to live here. Think of all the spiders and things.
Oh, there's lots of spiders out there in the forest, and not all buildings have to be neat and tidy. I'd like to live here. I think it would make a very good holiday cottage, because it's a forest building. You could see buildings like this built anywhere in the world where there's a forest, somewhere like Brazil or Borneo, and the natives would know how to build it, because it's very simple construction. Look how nice the space is. It's kind of flowing curves from these thinnings. These thinnings, with the thick end down at the bottom, are bent under their own self-weight, and they come up to the top here of this lovely blue canvas ceiling. It's really a very nice, happy, friendly building. I like it. I'd like to go climbing up there. I think I'll go up there.
Well, can't things change at the clap of a hand? I'm going to have some China tea. Would you like some, Prof? Prof? Prof, where are you?
I'm up here, Liz.
What are you doing up there?
Well, I'm enjoying looking at the structure. There's steel cables here in tension, and then steel cleats connected to bolts that go into the end of these timber thinnings. And that's very interesting. It's very unusual. It's a new sort of timber connection. That's the new technology. What they've done here is a very simple but effective detail. They hollow out the end of the thinning there with a cone-shaped hollow, and then in it they put a steel bolt which is going to have a nut on it, and it's in resin. Very simple, effective detailing. And what I like about this is it's a very traditional material. Timber is being used in an entirely new way. And that's what we hope happens with modern architecture. Now, this is my favourite one because it's completely irregular and it's different all the way around. And as you walk around it, you see different shapes, different possibilities of entrances, lovely curves. And it changes all the way. It's really like an organic thing. It really is a very, very happy structure. And what we've got to now is the part of the show we've all been looking forward to. The end of the Professor Lobster show. Are you glad we've got to the end of it?
Yes!
Are you really?
No!
Oh, well, I'm glad about that. Anyway, what I've done is I've really enjoyed myself. Now, what's this? Fantastic! We're going to have a party after. Crummy that, wasn't it? Ah, that's better. This is more like it. Now look at that. Anyway, what I've got to do is say thank you, helpers, for all the help you've given us. We've really enjoyed it. Liz and me, it's been really good fun. And cheerio to everybody out there at home. And remember, bye-bye then. No, if you're away, bye-bye. Bye!
Where will you go now then, Prof?
Where will we go? Oh, I'll go back to the bottom of the sea for a while, I think.
Will you be back?
Well, I hope so. You never know. But what you've got to do is look out for lobsters. And lobsters have this signal, remember? And remember the motto, if you don't know, ask. So keep on asking, everyone. And meanwhile, have a great time.
Professor Lobster.